Hi friends, welcome to follow up. Let's have a look at problem 435, non-overlapping intervals. This is a daily challenge problem, and in this video we're going to explain a solution based on sorting and checking. So actually we have a playlist on this kind of problem, which is we term it as interval merge problem. So there are actually quite a number of such problems in LeetCode and other places. For more information, you can check out that playlist. So now let's look at this problem. So here we are given a list of intervals. It's called intervals, where intervals is given in the form of a list of two elements. One is a start, and the other is an end. So we want to find the minimum number of intervals we need to remove to make the rest of intervals non-overlapping. So here, let's look at several examples. So in the first example, we just need to remove this one, 1, 3, right? So if you look at this, here is 1, 2, here is 1, 3. So we want to make remove 1, 3 so that we have larger possibility we can connect with other intervals with larger beginning, right? So in example 2, so these three intervals are identically the same. So we need to move 2 of them, leaving just 1. So we have output 2. So in the last one, so we have 1, 2, and 2, 3. So in this case, we regard these two intervals as non-overlapping. So we return 0. So with that said, let's also quickly look at the constraints. The interval length is bounded below by 1, which means non-empty, and bounded above by 10 to the power 5. This is a decent large number. And the second item is on the format of each interval representation. And the last one basically said that start is strictly less than end, and both are in between these two numbers. So with that said, we are ready to look at the logic and coding. So we are going to directly do the coding, and in between we are going to explain the logic. So now let's look at the overall picture. So here the strategy is that we are going to do sorting. So in other words, we are going to ordering one end of the interval. For example, here we are going to order the beginning of each interval so that we can fix one part and then compare the ends. So then we do comparison. So the key point is the following. Let's use an example to fix the idea. Assume that we have already sorted the intervals according to the beginning. So then, because here is 1, here is 2, the later intervals will have larger beginning. So in this case, so they have overlap, right? So we're going to remove 2, 4, right? So we are going to remove 1, 5. The reason is that we want to remove the interval with the larger ends. So if you change this 2, 4 to be, let's see, I'm going to write like 1, 5 and 2, 7. So in this case, we're going to remove 2, 7 because 7 is larger than 5. So we leave a smaller one so that we have more room for the later intervals. So with that said, basically once we grasp this point, so writing the code might be not that hard. So here I'm going to change this intervals to be a capital I just for the convenience of writing. So first I'm going to sort. So here let's see, I'm going to sort in place. So here let's give actually we don't need this function key. It will automatically sort according to the from smaller to larger order. But let's specify this. So here we can put a 1 key or 2 keys, x0, x1, right? In other words, we sort the first one according to the increasing order. And then if there's tie, so we're going to sort the ends from large to small. Or this second one is not that essential. You can ignore, or you can put a negative sign. So put sort from reverse for the second one. It does not matter. But here, let's see. We need to design a key, right? In some problems. So here is just natural order. So this is sort, and also let me introduce the length just for convenience of typing. So here let's introduce a counting variable. Let's call it result, which is also our return. And then we're going to have a start and an end. So let's see, it's I naught. So this is always true. The reason is that by assumption the intervals have a length at least 1. So we can always slice the first element. So with that said, we're ready to do the scan. So for I in range, so start from 1 and ending at n-1. So let's look at the current start and the current end. So this is nothing but capital I of I. So in this case, we want to check overlap or not. So here actually start does not play a role. And so, but let's first write this here, and then we simplify a little bit if needed. So now let's see, we check overlap, right? So in this case, if current start is less than the end, right? So here I write strictly less, because in example 3, like this situation, it does not regarded as overlap. If current start is strictly less than the previous end, so then we need to delete one of these two intervals at consideration. So anyway, so we need to increment the counting variable by 1, and then we want to set state of the previous the new interval for comparison. So in this case, as here, we need to remove the interval with larger ends. So here we are going to set the new end to be mean of previous end and the current end, right? And otherwise, so if there's no overlap, so previous interval, I should keep it as is. So also we can retain the current interval. Then the end will be the current end, right? So after this for loop, so we can actually collect the intervals we need to remove. So this way, we also get the counting variable final state. So we just need to return the result variable. So before we make simplifications and do some comments, let's first do a test. Yeah, it passes one test case. Now let's look at the generic case. Yeah, it passes all the generic cases. So here, let's comment this. So here we notice that after we do the sort, so this sort variable does not come into play. So actually we can actually ignore that. So the start, this is just the second element. Then we can just see current end, right? And then current start. Yeah, so here current start comes into play. Current start, current end, right? So then the previous one, the end in the first interval or the start does not come into play. So we can just ignore that variable. So now let's do a test again. Yeah, it passes all the test cases. So when it comes to time complexity, so here basically this is a for loop, right? Linear thing. And here, so we do sort. So we actually can just see is do sorting in natural order. Let's see, we can ignore this key. So this sort is O n logarithm n time complexity, right? N is the length. Now let's test again. Yeah. Anyway, so you can actually come up with other representation format of the coding, but the overall logic is demonstrated in this key point. So as we mentioned at the very beginning, so we have a playlist on this kind of interval overlap problems. So you can check those problems out. So with that said, I guess that's it for this video. Thank you.